In this video, we look at a question that appears to be an object in freefall, but if we're using energy considerations, we don't have to use any kinematics formula. So the question is two parts. The first part asks you to find the potential energy of a rock of mass equals 5 kg, and that is 30 meters above water, so that's the height. And that part is straightforward, so we're just going to use the potential energy formula. PE equals mgh, so mass is 5, gravitational acceleration number is 9.8, that's for g, and height is 30. And that equals 1470, and because it's an energy calculation, that's the same as works unit, so that's joule as the unit. Now B part, find the speed of the rock would hit the ground with if thrown down with an initial speed of 15 meters per second. So this rock is 15 meters above ground, above water, or it should be ground in here, isn't it? It says hit the ground or hit the water. So 15 meters above, and it's got an initial speed of 30 meters above, 30 meters above water, so 30 meters. And the initial speed thrown down with initial speed, that is going to be 15 meters per second. And if I give it a symbol, I could call that V0 or initial velocity U. But when you think about initial velocity and then this rock is going to come down here and have hit the ground with a final velocity, some of you might think about using kinematics formula because there's gravitational acceleration as this rock travels vertically downward, and then you can use a constant acceleration to find the final speed. It's a bit long actually, you can do that, but because this question says use energy conservation, and energy conservation is actually going to be much faster. Basically, this rock, after it's thrown at 15 meters per second, there's nothing else that's happening to it other than gravity. So it's a closed system, which means the initial energy, so total energy initial, has to equal total energy of final. And if I just write, well, we always consider both the kinetic and the potential energy at initial time, and at the end time we'll consider the final kinetic and final potential energy. That statement with a closed system is always true. That's the conservation of energy concept. Now, potential energy at initially, when this rock is above water 30 meters, we've calculated that. That's 1470, so we could plug in that number here. The kinetic energy initially, because we're starting with a 15 meter per second speed, so we can simply use this formula for initial. So a half times the mass, which is 5, and times the initial speed, that's 15 squared. That together has to equal the final kinetic energy plus the final potential energy. The final kinetic energy comes from the second V, the V final. So simply put, we don't know what that is because that's what we're trying to calculate. So simply keep that as a symbol, and times my mass is 5, and that's my final velocity that I want to calculate squared. What's the final potential energy? If it's hitting the ground, that's a height of 0, so there's no final potential energy left. So once you use the energy consideration to set it up, the only unknown variable in the equation is final velocity. So it's a one-step solution that you can get the answer to this question. Plug everything on the left side into the calculator. You have 2032.5. And on the right side, you have a half times 5 times V final squared. Divide both sides by a half times, so let's just write it down. 2032 divide the coefficient, which is half, times 5, like that, should give you V final squared. And then take a square root of that expression, will give you the final velocity. You can see a lot of times I don't really put a lot of intermediate steps in the calculator because I can always do that at last when I've got all the numbers sorted. Putting all the left side there into the calculator gives me the number of 28.5 meter per second. And that's the question done. One word of caution about using the calculator is that if you are doing a division of two numbers multiplied together, if you wrote it like this, divide by a half times 5, and if you've forgotten to put the brackets there, you will get a complete different answer. So let's just try that. That gives you, even if I say, let's take that square root. That gives you 14.25. And then it's exactly half of that. That's because you've not actually divided by the whole thing of half times 5. So that way of writing the division is wrong because you want to divide the whole thing of a half times 5. Okay, just be careful when you are doing calculator input. It's best if you type what you've written down as an expression exactly in the calculator. So if your calculator can do fractions, that's probably the best to avoid any errors. Right, thank you for watching.